Good afternoon, students. This is Arvind, Assistant Professor, Department of DBSIT, Kavali. So, in the previous classes, I discussed about third chapter, that is DC motors. And now, from onwards, I am going to discuss the fourth chapter of your subject, that is DC machines and transformers, that is single phase transformers. Okay. First, we will see the content. What are the contents we have, and what are the topics we are going to cover in this one. So firstly, coming to the introduction, that is the syllabus of unit 4, that is single phase transformers. So actually for every unit we have to give the introduction about that concept. So firstly I will give introduction to the transformers, and next I am going to discuss principle and construction and operation of single phase transformers, and then I am going to discuss equivalent circuit, and next I am going to discuss phasor diagrams at no load and on load conditions. And after that, I am going to discuss magnetizing current and effect of nonlinear BH curve of the magnetic core material and harmonics in magnetization current. And then I am going to discuss losses and efficiency and testing, and losses and efficiency and testing of the single phase transformer, that is open circuit test and short circuit test, and voltage regulation and sumpness test, separation of hysteresis and eddy current losses, and parallel operation of single phase transformers and auto transformers also here. So for the auto transformers, I am going to discuss the construction and principle and applications and comparison with two winding transformers. I am going to discuss in this chapter. So it is a lengthy chapter compared to the previous two chapters. Okay. So firstly, I'm starting with the introduction. Okay. So firstly, what is meant by transformer or single phase transformer? So the transformer is a static device, okay, which transfers the AC electrical power from one circuit to another circuit without changing the frequency, but voltage levels are changed according to the requirement. So here the frequency is constant, but voltage is changing. So this is the transformer construction. We have this is the basic diagram for the transformer. So in this transformer, we have the in between we have this circular, this rectangular shape. So this shape is known as transformer core. So for the to the transformer core, there is two windings. On the left side we have the primary coil, and the right side we have secondary coil. Okay, so on the right side we have the primary coil, and it consists of a number of turns, and on the right side we have the secondary coil, and it consists of a number of turns. These two are called as, one is on the left side one is called as primary winding, and on the right side we have the secondary winding, and in between we have the transformer core. So in between so in the transformer core we have some dotted lines with indicating with the arrow marks. So this is the flux. Okay, here the flux is flowing in the transformer core from the primary winding to the secondary winding. Okay, so it consists of the primary voltage, that is Vp, and secondary voltage, that is Vs, and Np means number of turns in the primary side, and Ns is the number of turns on the secondary side. Okay, so this is the transformer general construction. And coming to the transformer symbols, so on the left side of this one, actually we have two diagrams here. One is for the transformer construction, and another is for the transformer symbols. So this is the transformer symbol we have for the transformer. So this one, so on the right side on the left side we have the primary winding. So this is the primary winding, and in between we have the two lines, vertical lines. That one is the magnetic core. Okay, that one is the magnetic core, and on the right side we have the secondary winding. So this is a general symbol for the transformer, and then we have another symbol like that, that is in both ends we have the windings, that is primary and secondary. So in between two lines we have two circles connecting to each other. So this is the symbol for the transformer. Okay, I hope you understand this one. Okay, next, so the winding which is connected to the supply. So actually I said that on the left side we have the primary winding. So actually this winding is connected to the supply. So the winding which is connected to the supply is called primary winding. Okay, and also the winding which is connected to the load. So in the transformer construction diagram we have on the right side we have one diagram, so one notation, that is Vs, and secondary coil is also there. So that means, so the winding which is connected to the load is called secondary winding. Okay, and the symbol of transformer as shown in the below. So this is the symbol for the transformer. Okay, so actually I given one symbol in the last slide. On the last slide, so this one, this is the general symbol, and this is the main symbol for the transformer. So I already said that we have a rectangular shape. Okay, so this rectangular shape one is called as iron core or magnetic core. Okay, so for the magnetic core, the winding is connected. So the winding which is connected to the supply, so that is primary winding, and the winding which is connected to the load. So this red square box we have. So here the winding is connected to the load is called secondary winding. Okay, so here we have, I already said that, so the transformer works on the AC supply only, not DC supply. The transformer works on AC supply. Okay, not DC supply. So actually in the previous two chapters I discussed about DC. So DC generator and DC motors, those DC generators and DC motors are works on DC supply, but here the transformer works on AC supply. Okay, so here we have number of turns. The number of turns in the primary winding is NP, and the number of turns in the secondary winding is called NS. Okay, and the current in the primary winding is I suffix P, and the current in the secondary winding is known as second IS, and the voltage in the primary winding is notated with the Vp, that is V suffix P, and the secondary winding in the transformer is known as Vs. Okay, like that we have. So in between, so here the flux is flowing through primary and secondary windings. So here the lines is there with the arrow mark. So these are the flux lines, magnetic flux lines. Okay. Next, coming to the classification of transformers. So actually the transformers can be classified based on different aspects. So that is, firstly, based on construction, and based on the purpose, and based on the type of supply, and based on their use, and based on cooling used. So these are the different aspects. So depending upon these aspects, we are classified the transformers into different types. Okay, so firstly I will take the based on construction. So actually the based on construction, the transformer are classified as two types. One is core type and another one is shell type transformers. So the below diagram shows that the core transformer and the shell type transformer. So here we have the diagrams. So on the left side we have the core type transformer, and on the right side we have shell type transformer. So here these circular once is there. So this is the magnetic core we have. These are the stampings. If you observe this diagram carefully, you notice that it is a L shape. So on the core side we have the L shape, and on the right side we have the shell type transformer. It consists of a E type and I type. Okay, these are the laminations which are used in the core type and shell type transformers. Okay, why we are using these E and I and L shaped transformers in these things means I will explain later. Okay, so if you observe this diagram, we have the L shaped and E shaped and I shaped laminations, and then we have some circles like with different colors we have. So based on the color I indicated with here, that means the orange color gives the high voltage winding for both the transformers, and the blue line gives the low voltage winding, and we have similarly the higher voltage insulation and lower voltage insulation is also occurs in this one. So I will explain one by one with a detailed explanation for the core transformer and shell type transformers. Okay, so firstly I will discuss the core type transformer. So actually in core type transformer, the windings are given to a considerable part of the core. So if you observe the diagram, you will understand. So in the core type transformer, the windings are given to the considerable part of the core. So here I am giving the core to a considerable part of the core. The winding is placed in the considerable part of the core. Okay, considerable part of the core I given. Okay. Next, the coils used for this transformer are firm, wound, and are of cylindrical shape. Okay, the coils used for this transformer are formed, wound, and are of cylindrical type. That means circle. Okay. Next, such a type of transformer can be applicable for small sized and large sized transformers. Okay, such a type of transformer can be applicable for small sized and large sized transformers. So in the small sized type, the core will be in rectangular shape and the coils used are cylindrical. Okay, so in the small size type, the core will be rectangular. Okay, the core will be rectangular and the coils, so that is in the cylindrical shape. Okay, so you can see that the round or cylindrical coils are wound in such a way so as to fit the cruciform core section. So that means this is the core type transformer cruciform section. That means detailed construction. So actually I shown one diagram previously. So that is also the core type transformer, and this is also a core type. Both are similar, but it is in a cruciform section. Okay. So here also the windings are given to a considerable part of the core. So this one. So these circle shape is there, we have cylindrical shape. So these are gives the considerable part of the core. Here the windings are given to the considerable part of the core. So it consists of LV and HV. Okay, LV means low voltage side and HV means high voltage side. And in the bottom we have the laminated core, that is the magnetic core. Okay, and then on the right side we have high voltage insulation and low voltage insulation and LV winding and HV winding. So these are all windings are given to the considerable part of the core. Okay, this is the core type transformer cruciform section. Okay, so that is for large sizes type. Okay, what I shown before. So this one is the for the large sizes type, not for the small sizes type. Okay. So you can see that the cylindrical coils are wound in such a way so as to fit over a circumference core section. That means it fit over a magnetic core. It fit over a magnetic core. Okay. Next. So this is also one type of diagram to explain the core type and shell type construction. So if you observe this diagram, so the core is in the rectangular shape. Okay, the core is in rectangular shape. So here on the primary side, that means in the left side and the right side, we have some rectangular shape coils we have with the hatches, that means with the lines, crossed lines, and in between in the magnetic core we have some dotted lines. So these are the magnetic flux lines. Okay, so these are the primary and secondary windings. So if you observe, so to the core I am connected on the left side one winding and on the right side one winding. So on the left side we have the winding, it is connected to the supply, it is called primary winding, and on the right side I am connecting, that one is called secondary winding of the transformers. And so on the left side we have the core type construction, and coming to the shell type construction. So I know you understand this diagram. Okay, so here the core is divided into two parts. So if you observe this one, so actually the entire circular rectangular shape is there, but in inner part of this one, so we have connecting the primary and secondary windings. So actually in the core type transformer, the windings are in the outside of the core, and in the shell type transformer, the windings are in the inside of the core. So here the flux lines are also dividing. That means actually in the core type transformer, the flux is phi, but here in the shell type transformer, the flux is actually the total flux is phi, but here the flux is dividing, that is a phi by 2 and phi by 2. So half of the flux present on the left side and the right side. So this is the shell type construction. And so in the case of circular cylindrical coils, okay, in the case of circular cylindrical coils, they have a fair advantage of having good mechanical strength. Okay, so if you have a cylindrical coil, circular cylindrical coils, they have a fair advantage of having good mechanical strength. So the cylindrical coils will have different layers, and each layer will be insulated from the other. So here each layer will be insulated from the other with the help of materials like paper, cloth, mica board, and so on. Okay, next the low voltage windings are placed nearer to the core. Okay, the low voltage windings are placed nearer to the core as it is easiest to insulate. Okay, that means low voltage windings means LV windings. Okay, the next the effective core area of the transformer can be reduced with the use of laminations and insulations. So here some area of the core is effective. So the effective core area of the transformer can be reduced with the use of laminations and insulation. Next, so in both type of transformer, that means in the core type and shell type, the magnetic flux linking the primary and secondary windings. So you already noticed that one in the diagrams. So the magnetic flux linking with the primary and secondary windings travels entirely within the core. So the magnetic flux is travels entirely within the core with no loss of magnetic flux through the air. Okay, with no loss of magnetic flux through air. So in the core type transformer construction, one half of each winding is wrapped around each leg. That means on limb. Okay, leg or limb of the transformer's magnetic circuit. So that is shown already here. Okay, so this one in the core type construction. Okay. Next, the coils are not arranged with the primary winding on one leg and the secondary winding on the other, but instead of half of the primary winding and half of the secondary winding are placed one over the other concentrically on each leg in order to increase the magnetic coupling, allowing practically all of the magnetic lines of force go through both the primary and secondary windings at the same time. Okay, the magnetic lines of force go through both the primary and secondary windings at the same time. Okay, but here the coils are not arranged with the primary winding on one leg and the secondary winding on the other, but instead of half of the primary winding and half of the secondary winding are placed one over the other. Okay, on the each leg. Okay, next, so however, with this type of transformer construction, a small percentage of the magnetic lines of force flow outside of the core. Okay, so a small percentage of the magnetic lines of force flow outside the core, and this is called leakage flux. Okay, so actually the magnetic lines, the magnetic flux will flow on the inside the core, but small percentage of the magnetic lines of force flow outside of the core. So that one is called as leakage flux. Okay, so this leakage flux will be reduced by using the shell type transformer. Why? Because in that construction we are using the windings on the inside of the core, and the entire flux flows on the inside of the core only, not on the outside. So here, this is the shell type transformer. So on the left side we have the shell type transformer, on the right side we have the core type transformer. These are the symbolic representation for the core and shell type transformers. So in shell type transformers, the core surrounds a considerable portion of the windings. Okay, so here the core surrounds a considerable portion of the windings. The comparison is shown in the diagram below. So this diagram gives the comparison between the core type and shell type transformers. So if you observe the right side of the left side of the diagram, this is for the core type, and on the right side we have the shell type. Okay. So next, the shell type transformer cores overcome this leakage flux. So I already said this one at the last one, at the last explanation of the core type transformers. So shell type transformer cores overcome this leakage flux as both the primary and secondary windings are wound on the same central leg. So here the primary and secondary windings are wound on the same central leg or limb, which has twice the cross-sectional area of the two outer limbs. Okay, so that's why the shell type transformer cores overcome this leakage flux. So the advantage here is that the magnetic flux has two closed magnetic paths. Okay, you know already this one from the diagram. Okay, the advantage here is that the magnetic flux has two closed magnetic paths to flow around external to the coils on both left and right hand sides before returning back to the central coils. Okay, so this means that the magnetic flux circulating around the outer limbs of this type of transformer construction is equal to phi by 2. So I already said this point in the construction of the shell type transformers. Okay, so this means that the magnetic flux circulating around the outer limbs of this type of transformer construction is equal to 5 by 2, as the magnetic flux has a closed path around the coils. So this has the advantage of decreasing core losses and increasing overall efficiency. Okay, and next, coming to the transformer lamination. So actually in the first, in the core type transformer also I discussed this one. So in both the shell and core type transformer constructions, in order to mount the coil windings, the individual laminations are stamped or punched out from larger steel sheets and formed into strips of thin steel resembling the letters, that is E, L, U and I as shown below. So like that the shell and core type laminations are prepared or constructed. Okay, so the shell type laminations consists of E and I shape, and core type transformer consists of L and U shape laminations. Okay, L and U and I type laminations we have. Okay, next, so these lamination stampings when connected together, so these lamination stampings when connected together form the required core shape. That means either E or I or L, U, like that it covers. So for example, if we take two E stampings plus two end closing I stampings to give an E-I core forming one element of a standard shell type transformer core. So here to explain this one, I have taken one example, that is, that example consists of two E stampings, two E stampings, E shaped stampings plus two end closing. End closing means last one. Okay, I shaped coils, closing I stampings to give an E-I core forming one element of a standard shell type. So if you observe this diagram, this is the shell type. So this is the E-I laminations, and this one is the E-E laminations, and on the core type we have L-L laminations and U-I laminations. Okay, like that it will form. So these individual laminations are tightly butted together during the transformer construction. Why? Because to reduce the reluctance of the air gap at the joints, producing a highly saturated magnetic flux density. Okay. So next, the transformer core laminations are usually stacked alternately to each other to produce an overlapping joint with more lamination pairs being added to make up the correct core thickness. Next, so this alternate stacking of the laminations also gives the transformer the advantage of the reduced flux leakage and iron losses. And EI core laminated transformer construction is mostly used in the isolation transformers and step up and step down transformers as well as in the auto transformers also. Okay, so actually I shown the EI core laminated transformer construction is mostly used in isolation transformers, step up and step down transformers as well as auto transformers. And next, coming to the difference between core and shell type transformers, firstly I will start with the construction. So the first one is the circuit. So this is the general symbol for the core type transformer. So here in this one, the winding which is placed in the consumable part of the core. In the shell type also, here it consists of, here the windings and all are in the inside of the core only, but here the flux is half of the main flux, that is a 5m by 2 we have, because of here we have the two sides. Okay, and second one is it consists of two limbs and flux in both limbs is same. So actually core type transformer consists of two limbs and flux in both the limbs is same, but in the shell type it consists of three limbs. So 1, 2, 3. So it consists of three limbs and flux in two outer limbs. So here the flux is in the two outer limbs. Okay, is the half of the flux in the central limb. So those are all half of the flux in the central limb. Okay, and coming to the third one, a part of core is surrounded by the winding. So here a part of the core is surrounded by the winding in the core type transformer. Here in the shell type transformer, the winding is surrounded by the core. So in the core type transformer, the core is surrounded by the winding, but in the shell type transformer, the winding is surrounded by the core. Okay, and next coming to the fourth one, it consists of single magnetic circuit. The core type transformer consists of single magnetic circuit, and the shell type transformer consists of two magnetic circuits. And coming to the fifth one, its construction is difficult. The core type transformer construction is difficult, and the shell type transformer construction is easy. Okay, these are the difference between core and shell type transformers. And coming to the second classification, that is based on the purpose. So there are various types of transformers used in the electrical power system for different purposes like generation, distribution, and transmission and utilization of electrical power. So like that, we have to use various types of transformers. So the different types of transformers are step up and step down transformers, power transformers, distribution transformers, instrument transformer, compressing current and potential transformers. The instrumental transformer is classified into two types. One is current transformer and another one is potential transformer. And next we have single phase and three phase transformers and auto transformers, etc. But based on the purpose, the different types of transformers used is step up and step down transformers only among those transformers. So coming to the first one, that is step up transformer. So this type of transformer is categorized on the basis of a number of turns in the primary and secondary windings and the induced EMF. Okay. So step up transformer transforms a low voltage high current AC into a high voltage low current AC system. Okay, so in this type of transformer, the number of turns in the secondary winding is greater than the number of turns in the primary winding. So here the secondary winding is greater than the number of turns in the primary winding. That means if V2 is greater than V1, the voltage is raised on the output side and is known as step up transformers. So the voltage is raised on the output side and is known as step up transformer. So I will show the diagram, you will understand that one. Okay, next the step down transformer. So the step down transformer converts a high primary voltage associated with the low current into a low voltage high current. Okay, with this type of transformer, the number of turns in the primary winding is greater than the number of turns in the secondary winding. So that means if V2 is less than V1, that means the voltage level is lowered on the output side and is known as step down transformer. Okay, this is the diagrammatic representation or symbolic representation of step up and step down transformers. So coming to the step up transformer, so here we have two windings. One is primary winding, that is on the left side of the step up transformer, and secondary winding, that is on the right side of the step up transformer. So here the primary winding is less than the secondary winding. That means the secondary winding is greater than primary winding. So here if V2 is greater than V1, it is known as step up transformer. And coming to the step down transformer, so here it also consists of the two windings. One is primary winding, that is shown on the left side of the step down transformer, and the secondary winding, it is shown on the right side of the step down transformer. So it consists of, so in between the primary and secondary winding, we have two vertical lines is there. So that is the magnetic core. Okay. So the primary winding consists of V1 voltage and the secondary winding consists of V2 voltage, both in the step up and step down transformer. So if V1 is greater than V2, that is known as step down transformer. Okay. So this is the based on the purpose, and coming to the based on type of supply. That is based on the type of supply, the transformers are classified as single phase and three phase transformers. Okay, single phase transformer and three phase transformer. So this is the example for the single phase and the three phase transformers. But in this case, I am taking the core type transformer and the shell type transformer. So in the core type transformers, the single phase transformer is placed like this, and in the shell type, the single phase transformer looking like this. So okay, and in the three phase transformers on the core type looking like this, and in the shell type the three phase transformers looking like this. Okay, so I hope you understand this one. And next, so a single phase transformer is a static device works on the principle of Faraday's law of mutual induction. Okay, so a single phase transformer is a static device, works on the principle of Faraday's law of mutual induction. So at a constant level of frequency and variation of voltage level, the transformer transfers AC power from one circuit to the other circuit. You know this one, this is the basic definition of the transformer. So there are two types of windings in the transformer, this also you know. The winding to which AC supply is given is termed as primary winding, and in the secondary winding the load is connected. The primary winding consists of the supply and the secondary winding consists of the load. Okay. Next, coming to the three-phase transformer. So if the three single-phase transformer is taken and connected together with their all the three primary windings connected to each other as one, and all the three secondary windings to each other forming as one secondary winding, the transformer is said to behave as a three-phase transformer. So that means a bank of three single-phase transformer connected together which act as a three-phase transformer. So the three-phase supply is mainly used for electric power generation, transmission and distribution for industrial purpose. So and the three-phase transformer, so it is less costly to assemble three single-phase transformer to form a three-phase transformer than to purchase one single three-phase transformer. Okay, next the three-phase transformer connection can be done by star, it is also known as Y, and delta, it is also known as mesh. Okay, star and delta type. The connections of the three-phase transformer can be done by star and delta type. Okay. Next, so the connection of primary and secondary winding can be done by various combinations shown below. So the primary and secondary, so the primary winding takes the star and the secondary winding also takes the star connection, and the primary winding takes delta and the secondary winding is also takes the delta connection, and the primary winding takes star and secondary winding takes delta, and the primary winding takes delta connection and the secondary winding takes star connection. Like this we have the combinations of the primary and secondary windings in the three-phase transformer, star to star, delta to delta, star to delta, delta to star. Like that we have the combinations. Next, the combination of the primary winding and the secondary winding is done as I already said that star to star, delta to delta, star to delta and delta to star, like that. Okay. Next, coming to the based on their use, coming to the next classification, that is based on their use. So based on their use, the transformers are classified as a power transformer, distribution transformer and instrument transformer. So I will explain one by one. That is, firstly I will take the power transformer. So actually the power transformers are used in the transmission networks of high voltages, transmission networks of higher voltages. So the ratings of the power transformers are as follows, like 400 kV, 200 kV, 110 kV, 66 kV and 33 kV. These are all the ratings of power transformers are used in the transmission networks of higher voltages. So they are mainly rated above 200 MVA, megavolt ampere. kV means kilovolts. Okay, so these are mainly installed at the generating stations and transmission substations. Why? Because to transmit the power. Okay, next they are designed for maximum efficiency of 100%, and they are larger in size as compared to the distribution transformer. Compared to the distribution transformers, the power transformer size is large. Next, coming to the distribution transformer. So this type of transformer has lower ratings like 11 kV, 6.6 kV, 3.3 kV, 440 volts and 230 volts. Okay. Next, they are rated less than 200 MVA and used in the distribution network. So previously the power transformer used in the transmission network, but the distribution transformers are used in the distribution purpose only to provide voltage transformation in the power system by stepping down the voltage level where the electrical energy is distributed and utilized at the consumer end. Okay, consumer means ours. Okay, next, the primary coil of the distribution transformer is wound by enamel coated copper or aluminum wire. A thick ribbon of aluminum and copper is used to make secondary of transformer, which is a high current low voltage rating. Okay, next, the resin impregnated paper and oil is used for the insulation purpose. Okay, the resin impregnated paper and oil is used for the insulation purpose. And next, coming to the instrument transformer. So these are generally known as an isolation transformers. So the instrument transformer is an electrical device used to transform current as well as a voltage level. Okay, the most common use of instrument transformer is to safely isolate the secondary winding when the primary has high voltage and high current supply, so that the measuring instrument means energy meters or relays which are connected to the secondary side of the transformer will not get damaged. For that purpose, we have to take these measures. Okay, precaution. So the instrument transformer is further divided into two types. One is current transformer and another one is potential transformer. So firstly, I will discuss the current transformer. So here the current transformer is used for measuring and also for the protection. Okay, next, when the current in the circuit is high, to apply directly to the measuring instrument, at that time the current transformer is used to transform the high current into the desired value of the current required in the circuit. That's why we are using the current transformer. Next, coming to the potential transformer. So the potential transformer is also called as the voltage transformer. Okay, here the primary winding is connected across the high voltage line whose voltage is to be measured, and all measuring instruments and meters are connected to the secondary side of the transformer. That's why the primary winding is connected across the high voltage line. Next, the main function of the potential transformer is to step down the voltage level to a safe limit or value. So the primary winding of the potential transformer is earthed or grounded as a safety point. Okay. Next, coming to the last classification, that is based on cooling used. So based on their cooling system, the transformer are classified as nature cooled type, oil cooled type, forced air cooled type, and water cooled type. Like that it is classified. And coming to the cooling of transformer, the cooling of transformer is the process by which heat generated in the transformer is dissipated or treated to the safe value, and this is achieved by various cooling methods of transformer available. So the major factors for the generation of heat in the transformer is the various losses like hysteresis, eddy current, iron and copper losses. And among all the various losses, the major contributor of the heat generation is the copper loss or I square R losses. Okay. Next, coming to the nature cool type classification. So this method used for a small rating of the transformer and not recommended for a large transformers. So in this method, the ambient air used for the cooling the transformer. Natural air will be the ambient air used for the cooling the transformer. And next, coming to the oil cooled type. So here the oil cooled type consists of several types, that is oil natural, air natural, that is also known as ONAN. And second one, oil natural, air forced, that is ONAF. And third one, oil forced air forced, that is OFAF. I will discuss one by one. First I will take oil natural, air natural. So this method used for the transformer up to the rating of 50 MVA, and this is the simplest method of cooling of the transformer up to this rating. Okay, so in this method the transformers fitted with a panel radiator for oil natural circulation. So here we are using a radiator which is used to circulate the oil into the system in the network or circuit. And coming to the oil natural air forced. So in this method, panel type radiators are provided with cooling fans. The fans are switched on during heavy loads only. And coming to the last one, that is oil forced air forced type. So in this method, the oil forced to circulate within the closed loop of the transformer tank by means of oil pumps. Like this, we classified the transformer into different types. Okay, thank you. And in the next class, I'm going to discuss the working principle of the transformer and EMF equation of the transformer. Okay, thank you.